All right, so let's see. Good practice problem would be integrate from 1 to 3 of, we'll say, x plus 5 dx. Let me make sure that that's a pretty close one. Yeah, I'd say that's pretty close. Well, here's a better idea. Let's say 3 over x plus 5 dx. Yeah. Because that seems, yeah, that's pretty close, I'd say. Okay. So, formula for trapezoidal. We're going to start with, well, actually, I'll write it to the side. So that way we know the kind of question. Using single trapezoidal rule, T1, estimate the integral is, okay, so the light blue would be your, like the question, basically, on how it's worded. So this means n equals 1. And our formula is h over 2 times f of x sub naught plus f of x sub 1 minus 112 h cubed f double prime of that nasty boy. So this guy, you don't actually have to calculate. That's just error. The like theoretical calculatable error, which yeah, you won't have to do because you won't be given the xi, and yeah, it's cringe. Yeah. Anywho, so and your h would be h equals b minus a. Your x of naught in this case is your a, and your x of 1 is b. So to solve, I'll go into blue so that way it's separated a little bit. 1, 3, 3x to the negative 1, 5 dx equals, so we'll say to find, I'll draw it off to the side in a pretty little box. I'll make it pink. Ooh. I like to keep my things kind of separated, especially when I'm finding the constants. So h would be, in this case, 2. X sub naught is 1. X sub 1 is 3. So back over here, h over 2, don't do that, is 2 over 2 times f of x sub naught, which is 1, plus 1, 3. And then that's what 1 times, plug in 1 for this, that's 3 plus 5, which is 8. Plug in 3, 1 plus 5, which is 6. And it should equal 14, I think. Pretty sure. Yeah. And that's that guy. And then now, using double trapezoidal rule, T of 2, the estimate is back here. Rewrite our boy 1 to 3 of 3 over x plus 5 dx is equal to, so now since it is not a single trapezoidal, it is now compound trapezoidal. Our formula changes, so we've got h over 2 times f of x sub naught plus the summation from I equals 1 to n minus 1 of 2 times f of x sub I plus f of x sub n minus ugly error boy that we're not going to write out because I'm too lazy to write it out. Anyway, so in this case, we'll go back over. Oh, no, don't do that. Surface can be so stupid sometimes. To shape. We'll toss this guy over here. And we're going to say, oh, we're going to write out, I suppose. In this instance, our h is b minus a over n, where our n is equal to 2. Boop. Boop. X of naught is a, again. Our x of I is equal to a plus ih. And then x sub n is equal to b, where, oh, why did I do that? Sorry. It's gotta be pretty. Where I is equal to 0, 1, 2, da, da, da. And actually, I think it technically starts at 1. Yeah, because this guy, our summation starts at 1, so it would be 1, 2. Anyway, not super important. Because you likely will not be asked to do more than 2 trapezoids. I don't think.
Yeah.
Hopefully.
Yeah,
not.
I was gonna ask you how you can switch those up, like whether it's the single or the double, like if it asks you to do the third and the fourth, but in the code, but I don't know if that's.
You could, but I doubt you will be asked to, because doing it by hand for more than 2 kind of starts to take a while because you have to do the whole summation thing.
Yeah.
And it gets really annoying. I show you how to do it in the code that I sent y'all, but I mean, my gut says there's like a 90% chance that you'll only have to go up to 2. So my gut says. Hopefully you won't have to do more than 2, but
yeah,
the process isn't super complicated. It just takes a while.
Yeah.
So anywho, we'll write our constants over here. We know n equals 2. H is equal to b minus a over n should be 1, because our last case it was 2. So over n equals 2 is 2. Yeah, 1. H is 1. X sub naught is 1. X sub n is 3. And so then you also have to find your different x sub i's. So in this case, so for x sub 1, that would be a, which is, or yeah, x sub 1, a, which is 1, plus I in this case, which is 1, times our h, which is also 1, which is 2. You don't have to go up to 2, because in this case, there's only going to be I equals 1. I only goes up to 1 anyway, because this top guy right here determines that since n is 2, yeah, it's stopping at I equals 1. So it's up there.
So
What's up?
No, my bad. Yeah, I was about to read. I forgot I wasn't muted. My bad.
Because if I actually almost made this mistake, I remember on the exam, because I started it and I was like, oh, no. Because if n were 3, then that would change a lot of things. But then you would have to find your highest I would be 2, and that's when you'd have to find, x of 2 is 1 plus 2 times h, which our h would be different because our n is different, and that would be 2 over 3. But all of these values, well, not all of these, your x would change, your h would change, and your n would change. All of those would change if your n changed. But since they didn't, that's where we're stopping. Because that 1 would have been 2/3 instead of a 1. Anyway, if that didn't confuse you more, did it?
No.
Okay. I didn't want to.
I'm just wondering. Yeah, no, I had to solve this. I solved this one already by hand. But I don't know. I just don't get from here where you go. I guess I'll let you finish it, but I don't get here where you, what I originally asked was like how to find the,
Right.
whatever you said with the, can't remember what it was called at Romberg, but
yeah. I'm getting there.
Yeah,
you have to find both steps before you can get to the Anyway, back to this boy here. Our integral from 1 to 3 of 3x to the negative 1 plus 5 dx is equal to 1 over 2 times f of 1 plus, in this case, it would only be 2 times f of 2 plus f of 3. That, so 1/2. We know f of 1 is 8 plus f of 2, in this case, 3/2 plus 5. Plus our f of 3, we know is 6. So if we multiply that through, that's 3 plus 10, 6. So we got 8. 13 plus 8 is 21, plus 6, 27. 7, which is a mildly ugly number. That's, I know, simple algebra. Shit. 12.
13.5.
Thank you. That's like, oh crap. What is 27? Thank you. Okay, that's our boy. So one like sanity check that you can always do is, since you likely will be asked to do like 1 and then 2, as long as these values for 1 trapezoid and 2 trapezoid are really close, like within 1, I'd say.
Yeah, it should be close. Yeah,
you're probably going to be right.
Yeah.
Anywho, so then the next question becomes.
So before you, what I was confused on here is in the thing it doesn't have anything on. Hold on one second. Let me look. I have like literally 27 tabs open. So I have to navigate. Not that tab. Yeah, so it has like I1 and I2, but I don't know. There's 2 things for OH to the 4th. So should I like flip a coin for which one I use, or like which is?
What do you mean there's 2?
Wait a second.
The I?
Okay. Yeah, so there's I. All right, so do I need to
you good though?
All right. Script. Oh, I can't screen share. All right, so there's 2 formulas. I1 equals 4t2 minus t1 over 3. And then there's I2 equals 4t4 minus t2 over 3. So which one do we use?
So you base it on the number of eyes that you have, which is the number of trapezoids that you have. If you only had 2 trapezoids, you would stop at the I equals 2, because this I means the number of trapezoids, right? N equals 1, 2, or 3. So you can only go down as far as the number of trapezoids that you've done the maximum number of. And then you base the column on what estimate of the Romberg you're choosing. So OH2, you would be in, so you only have up to 2 trapezoids and you want the OH2 of the Romberg, you can only find T2, which is just the trapezoidal of 2 trapezoids. But if you want, or if you only have 2 trapezoids and you want the OH4, then you find I sub 1, which is the 4t2 minus t1. Now, if you have 3 trapezoids and you're asked for the OH of 4, then you choose.
I get it.
Yeah.
So the 13.5 is T2, 14 is T1, basically.
Yes.
Right. All right. So that answers that question. Yeah. So what I was referring to, I don't even know if I tried to screen share, but people can't do it at once. But basically, the I2 I was talking about had like T4, but I guess that's only for If we do like 4 trapezoids, which you said you would do. So yeah, I don't have to worry about it. So
yes, this is true.
Thank you.
Plus, you're like very, very, very likely to only be doing up to 2 trapezoids, in which case you only really have one. Well, you have 2 technical Romberg estimates, but only probably one that you're going to be asked for, which is going to be the OH4. And that one is like actually mad simple. So that would be this guy. We'll say we'll do this. For clarity's sake, equals 4t2 minus t1 over 3. So I sub 1 equals 4 minus, what was it, 14. All divided by 3, which, I'll pull up my calculator real quick. .5 minus 14 divided by 3. I sub 1 is equal to 13.33 repeating. And that is your final answer. You will also be asked, here it is. So you might be asked in between these.
Oh, wait, give me 1 second. I'm trying to do that by hand, so I'm gonna get lost. 1 second.
I'm moving this down.
All right, so quantity of 4.
What are you trying to do by hand?
No, I'm just trying to like finish doing it. So let's see if I get the same answer. No, because I'm gonna get lost, but same thing in calculus. Like, I don't know, the teacher did something, I wanted to finish it. All right, I got the same. What'd you get? 14.1666. Wait, I got a different answer. Oh, it's because I switched T2 and T1. I'm an idiot.
Yes. Make sure you read carefully.
Yeah, 13.3. You get 13.3.
Yeah, 13.3.
Yeah, that's what I got. Yeah.
I made sure to write in here to make it easier, the notation. And the question will probably ask you to, T1, T2. That'll make it easier in terms of choosing which Romberg equation to use as well. But anywho, so you might be asked in between these 2 questions of finding the trapezoid. Let's see, how exactly is it worded? Let me make sure so I can help you guys the maximum amount of possible. Okay, yeah. So using the results from class 2 computing. Oh, another spell. The error in the single
We have until 6, right? Just want to make sure.
Yeah.
Okay. All right. Cool. Thank you.
Okay. So you might be asked to find the error in one of them, in which case it's a good thing that you had already found the estimated integral for 1 trapezoid and 2, because formula for it, let me pull it up, for trapezoidal anyway, should be e to the n equals 4/3 t to the n minus t to the 2n. So in our case, E1 equals 4/3 absolute value T1 minus T2. So E1 is 4/3 absolute value of, what is it, 14? Yeah, 14 minus 13.5 times 0.5, which should be, that's what, 4/6 which is 2/3, which is 0.66. We'll round it off to 7. But yeah. Ta-da! And that's pretty much exactly how you're going to be asked that section of questions.
Cool. Let me see what else. All right, so let me see. Where was it? I had everything. All right, so I talked to Kasab, and he said that quadratures would be on it, and I have no idea how to do quadratures.
They will be on it.
Yeah.
So
I don't know. He was talking about like mapping. He said you'd have to like map a quadrature, and I was like, okay, all right. I guess I wasn't paying attention in class. I was like, I don't know what that is. So I don't know. Because I know like with the Gauss, the ones that it goes from like -1 to 1, but I have no idea how to. I don't know. So
okay.
And it's a weird question, but.
Hi, Charlie. Of course, good luck on your exam and everything else. Thank you for showing up.
Thank you. See ya.
Hi.
Bye.
So back to your question. Do you, that makes me question how much of the lab you paid attention to. So
What do you mean? Which one? Which one? Which lab?
Quadratures? We had an entire lab on how to do Gauss quadratures.
From when? How many weeks ago?
What?
How many weeks ago? When was that?
There's a couple. I think it was Project 5.
You trolling? No way. It's actually Project 5.
My gut says it was 5. At least I think it was. But
oh yeah,
mapping,
it is. Yeah.
Mapping quadratures is something that we went over. So the essential thing, and I went over this when we did the lab. There's an essential couple of things that you have to find every single time you do it. That is good practice just to find before you start actually trying to find the quadrature. Is first you find your linear mapping, which the formula is x of your ugly xi boy equals b minus a over 2 times this guy. Well, I won't write it like that because then it'll look like it's a function and it's not. Plus a plus b over 2. I have this like written on one of the pages. That's what he means by mapping it. And then you find the Jacobian, which is y equals b minus a over 2. Well, we'll not say y, we'll say j.
Okay, so mapping is basically you transforming the integral into another function to where it'll equal the same thing if you change the boundary conditions from -1 to 1 instead of a to b. Does that make sense what I just said? Is that?
I'm not great with auditory processing. So
Okay.
I'm taking a second to try to process
all
it.
right, so mapping is basically converting what's inside that integral into a new function so that it evaluates the same thing if it's integrated from -1 to 1, you know, because if you had integral from 5 to 10 of, you know, the same thing you had on that screen and you mapped it and put it -1 to 1, it would be the same thing. Yeah, that's what else. All right, cool.
Yes.
Can you, I guess, map that same integral? I guess you went over, or like another one. I don't really care what integral it is, but can you like go with an example? Wait, it should be easy. Hold on a second. It's probably
it's really
easy. Yeah, it's b minus. All right.
And for quadratures, you'll also be given your weights and your xis.
Yeah. So A is 3, B is 1, right? From that example you had earlier. Go up.
B is 3, A is 1. A is lower limit, B is upper limit. Always.
A is the lower limit. What? I thought B was the higher.
Nope.
Dude, how did I pass calcul? I swear I got an A in calc 3.
Are you okay, bud?
A is 1, B is 3. So that's 2/2. I don't know how to write that xi. It looks like you square. Looks like you
I
just
honestly
YOLO'd it
just like
and
xis. I just write a squiggle and then
yeah.
run with it.
All right. So I've literally xi plus 2 is what I have.
What's up?
What I got is just xi plus 2, so I think it's really easy. Yeah, that's a lot easier than I thought. Yeah.
Because when you're going to be asked a question, it'll be like, what is the linear mapping for this integral? The answer will be like looking something like that. It'll be like xi plus 2.
Sounds good.
It won't be just a number, which confuses some people sometimes, but yeah. Let me take a look at this to see what else would be asked. So it'll be asked to find the mapping and the Jacobian. And then you will be given the weights and abscissa and asked to do a certain number of points quadrature. So it'll be like, find a 2-point quadrature with the weights provided, which 2 points the easiest because your weight's just 1. And your xi are plus or minus square root of 3/3, excuse me. I mean, I could write that out, but I mean, if you want me to, I can try to work it out, but it's up to you.
You're eating something. I heard that bag rustle. I was like, she's eating goldfish.
Actually, no, it's M&M's this time.
Oh shit, really? Yeah, it's goldfish are good. I'm allergic to like everything though. I ate something. I'm allergic to jalapenos, and I literally had like chips and dip yesterday night, and my stomach ached for like the whole day. I was like, dude, this sucks.
I'm sorry, dog. That's tough.
All right. Happy.
I love jalapenos. Sorry, hold on. Oh, okay. Let me see. Oh. Do remember for quadratures, there's a couple of conceptual questions. Some concept. Some math. There's a couple of conceptual questions and a couple of math questions. Like, remember, this was on like multiple. It was on both lab quiz and I think it was in a class quiz. Can integrate exactly.
Oh, integrate that psi function thing.
-1. No, you can integrate whatever integral using quadratures based on the order. (2n minus 1). So if you're doing, say, i.e. 2 can integrate. Actually, what's a better way to, I didn't word that very well. Up to, well, hold on, can integrate exactly.
Is there any background noise, by the way? My speakers, my mic. I don't know. There's a lot of background noise. I don't know if you can hear it. I don't want to.
No, I can't hear it at all.
All right, cool.
Anyway, but yeah. So remember the this guy here, the 2n minus 1, for finding what order you can integrate exactly on for however many.
And then there's the n cubed one too, but I think the n cubed one is for something else.
What'd you say?
Right? Oh, I probably shouldn't say anything. I sound like an idiot. I'm
No,
thinking
I
of
like
something
genuinely
else.
couldn't hear you. What's up?
There's like a 2n squared one. Or there's like another one that we're supposed to use. Like, but I'm thinking about last test. That's for the coefficient or something like that. I don't know. I can't remember.
2n squared. I don't remember anything.
Or it's like n. I don't know. I can't remember. Kn squared, I think. For, I don't know. It's Gauss Seidel or something like that.
I do not remember. Not gonna lie. I don't.
Conditioning,
Nothing
though.
rings a bell. Oh, that's what I was right. Okay. What else? Oh, well, I guess I wrote it out multiple times. The steps. Because, well, I would say find your mapping. Step 2, find Jacobian. Step 3, actually, here's a better idea. Better wording for this.
Yeah, I was gonna ask you to like demonstrate that because I don't know. I was kind of confused with it.
What's up?
Because I thought you mentioned earlier like the abscissa, the whatever it's called.
What's this line?
All I know is in the notes it says ABSC. ISSA.
Yeah, abscissae, however you want to say it.
Abscissa.
Based on Latin, it would be abscissae. But anyway, what's your question?
I don't know. You were mentioning. I don't know. I was just saying that if you could like show me how to like plug it in, or you could. Is it in the notes and stuff? Because I don't remember that unless I just wasn't paying attention. I remember like the negative 1-to-1 in the mapping, but I do not get, because I tried to basically what you did with the last problem. I got the function, I threw it in, and just integrated from negative 1-to-1. But I guess that's how you would do it, right? Is it that simple? Or
so not exactly. So hold on. There's like an exact formula for it. It might be in your formula sheet. But so after transforming it or linearizing, mapping it, however you want to say it,
yeah,
becomes equals summation of, it's supposed to be an n equals 1 to n of your weight times your function of x sub n plus your error. But your error, you don't need to be concerned with. There's a whole like nasty, disgusting function to find the error, but she's pretty thick. It's in my review sheet, but I don't think you need it. Anywho, so for example, like a 3-point.
wait, that W is
Your
the heck
weight.
is that?
Your W.
Okay, so I remember that with sum of squares. That's why I was kind of confused. I was like, I thought W was like with sum of squares, determining if it's too small or too large. And then I saw this and I was like, wait a second. I don't know. I got totally confused when you drew that. I was like, wait. I don't know, because I'm in statistics and we use W for like determining if it's a valid result or not. So I was like, oh, but I don't know. Sorry, I got confused.
It's okay. It's been a fat minute since I took statistics, even though I have to take it again this year for engineers. So So I have no idea what you're talking about, but alas. That's like, so the first one is your general equation formula. And then the second one is like what it would look like for 3-point. Say 2-point would be 1-to-1.
The 2-point one is probably the relevant one here, right? Because I don't think we did 3. Or at least the one we did. I don't know, you're saying you have to do 3 repetitions. So I thought, you know what I mean? Like the 2-point one would be.
You're likely going to be doing 2-point.
Yeah. So I remember you said earlier, like 3 points of tunnel works. That's why I was, or I mean, 3 repetitions for trapezoid. That's why I was saying that.
What?
You said 3 repetitions for trapezoid is a lot of work, but I think I'm mixing different concepts up. But.
It's more so 3 trapezoids is a lot of work because not only do you have to find multiple different x's, but then you have to find multiple different f of x's, and then you have to sum all of those f of x's and then multiply them. So it becomes a lot because it's like a lot to handle. Gauss quadratures with 3 wouldn't be a huge deal. It just becomes a lot more math too, because your weights are no longer 1. They become non-1. They're like, I don't remember. They're ugly numbers. So finding a 2-point of the function that we just did would become 1. Was it 3 over x is 5? Is w1 f of x of 1 plus w2 f of x of 2. I'll put off to the side. W1 is 1, W2 equals 2. Xi.
Are you going to post this? Anthony has to leave.
Am I going to what?
Are you going to post this? Anthony just asked in chat. Anthony has to leave. He wants to know.
Oh, am I going to post it?
I mean, you can, I don't know, you can download it and send it to me and I'll send it to Anthony. I won't send it to the whole Discord. If you don't want to, I don't know. Technically, I'm recording on OBS, so I mean, I could just send screenshots, but.
I mean, did you say you're recording it?
Yeah.
Without my consent? I could sue you for that.
I always do that, but it's not, it's only voice recording. I don't know how to do screen recordings.
Interesting. Fair enough. I'm not actually mad, but I mean, I can post it, I guess, because it's not like
I mean, I can stop, but no, it was just because I can't remember. It was because like if I'm not recording, then I'll have to like keep stopping to like understand that stuff. But if I am, then I can just rapid fire ask a ton of questions.
It's okay. I mean, you don't have to stop. Though I do recommend in the future, if you're going to record professors, do ask. Because there's professors that freak out if you record them and they find out and you didn't ask.
So fun fact, it's only illegal if it's a private conversation or phone call. But like a public lecture, you have free reign to record, but a professor will still whine about it because you have the ability to give out their information for free that they want to charge other people for.
Oh, so is that why like whenever my dad's ex-wife calls him, he always has to like legally tell her that he's recording a phone call?
What?
Well, that's interesting.
Yeah, I really have to go. I'll talk to you guys later.
Okay, bye, Anthony.
Not gonna give me an answer.
I'll post it.
I kind of wanted an answer to that. I don't know. I thought that was. I guess not.
I'm gonna guess the answer is yes.
Yeah, I assume so. All right, sorry, that was off topic.
Good. Anywho. What are the weights and xis for this? Okay, so xi of 1, negative square. What the heck just happened to my writing? Negative square root of 3 over 3, and positive square root of 3 over 3. Those are all going to be given.
What? Wait.
What?
Why the hell? Why are those not 1? Because it's.
I'm sorry.
You know what I mean? Because like the variable in that thing would be xi. But so why is it not from -101? You get what I'm saying? It's like I don't know. I'll just let you finish. Too bad I interrupted.
I don't know the answer to that question
Okay.
because I don't know this well enough to know why.
Alright.
All I know is
Cool.
this is how to do it.
All right. Sure.
Because then it would just be 1 plus 1 times f of square root 3 over 3. And that should be the answer. And that's it. And you'd plug in these values into your function to find them.
Okay, so let me write this down for a second. So I got W1 times f of x1 plus W omega 2 times f of x2, where x1 equals
I don't feel like
psi1 and psi2 equals x2 plus x2. All right. Let me see something. So if
I did do this somewhere else. I knew it.
uh-oh.
Okay. Wait a minute. Oh, hold on.
Oh.
My formula is not complete. There.
So f of psi1. Oh, okay. So this is where that formula comes in. Okay, I get it. All right, so we get that formula we had earlier, and then we plug in. I get it. All right. So 1 second. I'll work this out. Psi1 f of psi. 5 times. I really hate drawing the psi thing.
Yeah, I just do a squiggle and it works.
Yeah, I'm literally just gonna. I don't know. I might. I guess you're the one grading my work, so if you don't care, then it's what it is.
Yeah, I don't care. Do what you got to do. Mine are ugly, so.
Negative square root 3 over 2. W's, do we have to find W, or is that going to be given?
Given. All W's and X's, all weights and Xi, all weights and abscissi are going to be given, which is why I put them in that box and wrote given. This.
Why am I not getting the correct answer? Well, so, all right. I mean, so every time though, the size is going to cancel out. So if the size are the same number, and you have the same function. So if you have like 5x plus 3, and or 5 xi plus 3, every time you plug in xi, whatever xi is times just gets canceled. Correct? I mean, because it's plus. You get what I'm saying?
Sorry, hold on.
All right. So let's say, all right, I can annotate. So all hell is going to break loose because I just realized I have a power of annotating. All right. So let's say f of psi. Yeah. Right. So f of, all right. So let's say if we have that, I just made that up. Every time you plug these in, this term's going to cancel because you have negative of one number, positive of the other. You plus them together, it just cancels.
That only works with 2 point.
Okay.
3 point and onward is different.
So I guess it's just the constant plus each other. It's kind of weird, but whatever.
So you're correct when it comes to 2 point, but once it gets into 3 point, it's not the same numbers. It's like let's see, what was it? It's like list of It's like a whole thing. There's a cool little GitHub thing. Yeah, so like once you get into 3, your xi values are like, oh, actually, even 3. You know, actually, now the closer I'm looking, the more interesting it is. Because, so for 3, your xi1 is 0, xi2 is negative 0.77, xi3 is 0.77. 4, 1 and 2 are plus or minus. They're the same values but negative, and then 3 and 4 are the same but negative and positive. That's interesting. They're all like that. There's probably a conceptual reason why, because they're theoretically the solutions to Legendre's polynomial. I don't even know. I wish I understood it better than I do, but alas. All I know is fine dining and breathing.
All right.
And I know how to plug numbers in to get the answer.
Can you demonstrate that? Do it with this one. Plug numbers in and get the answer.
You want me to like fully finish working it out? Is that what you're asking?
Well, I mean, I give you the integral for the last problem, I guess. Then you could, but
or are you asking me to?
I'm asking you to find. What am I asking you to find? The value of the integral. Because I don't understand. I don't know. It just seems weird that it just cancels. But
So you want me to finish working it out? Is what you're asking?
yes.
Okay. Oh, all right. Hold on. I'm gonna write this last step down. No, why is it not? There we go. Okay. There we go. So x of xi, we'll say 1.
If I PayPal you, can you stay in the Zoom call until like 7? I've done that before with other TAs, but I don't think you're allowed to. But
You've done it with other TAs?
yeah, I paid him like $50 like an hour. But, yeah.
Jesus. What? I don't want you to have to pay me. I mean,
I will. I don't care. But I don't know.
the problem
It's
is I've got vibes homework due at midnight.
Okay. All right. Well then, yeah, it's not a good idea.
But if you want me,
I'll just stop interrupting because I'm killing the productivity.
all right.
My attention span's terrible.
Anywho, okay, wait. Okay. So back up to this. Our mapping b minus a over 2. So we said that's 2 over 2 is 1. So it's xi plus 2, right? Yeah. 4 over 2 is 2. Yeah. So in this case, that's like that. That's 1. Those are our x of x's, or f of x of xi1, and f of x of xi2. I'll plug this into a calculator because it's a lot faster than I am. So let's see, that becomes negative 3. So it's 3 over that. Plus 5. So this is 7.1087. And this is 6.1639. So those are those boys. These our weights are 1 on both.
All right, I'm lost. How'd you get those? Wait, all right, so hold on. Well, what's the function you're using for the xi equation earlier? So I can work along this with you.
The function, what are you talking about?
Kind of. All right, so okay, so you got xi plus 2. Okay, that's what it is. My bad. All right, so you got x plus xi equals xi plus, I'm just squiggling that shit. I don't care anymore. All right, how did you get oh, that's a 3. Okay, I thought you had skirt 3 over 6. I was like, dude, I'm lost. All right, that's a 3. My bad.
You're good.
They're both 6.
J, B max 2. There, done.
Okay, so some witchcraft happened somewhere, and I just got lost. All right, f of xi of 1. How did that transpire?
Okay. So you see the x of xi of 1 right here, this -3 or negative square root of 3 over 3 plus 2. This guy, you see him?
I see this.
Okay, you plug in, yes. So you plug in this first one into our original function for x. So it becomes 3 over negative square root of 3 over 3 plus 2.
That's why.
Plus 5.
Okay, that makes a lot more sense.
You plug that in because it's your function of this new x value.
Okay, so it's, oh shit, that's beautiful. Come on. All right.
Because see, it's down here, right here.
All right, so I got 3. All hell's gonna break loose because I finally have the power to draw on your screen. All right, so I have 3 divided by, all right, so I have 3 divided by x of, I put an extra parentheses there.
Mm-hmm. Yep.
All right, so that's it. It's easy.
Yep.
All right. Cool.
So you plug that one in and you do the same thing for your x of 2. You find that new value. You put them in here like this. You multiply by your weights for each, which in this case is just 1 for each.
Yeah.
And then you scale the whole thing by your Jacobian, which our Jacobian is just 1 because we found that, that's just b minus a over 2, which is up there. And ta-da! And so technically,
Oh, I haven't even asked you about Euler's method yet. Damn, shit.
I can try to speed through it if you want.
Yeah. What else is nice? All right, so and trapezoidal. Well, I mean, wait a second.
You already went through trapezoidal.
Yeah. I do remember he talked about time steps and stuff in lectures, and if he brings that up, I'm screwed. I have no idea to do that.
What do you mean?
He talked about time steps and how sometimes there's constant, you have to fit time steps to certain things. But I don't think the Euler's, the modified Euler's method has time steps in it. So it's not the same as what we were doing earlier because there's no time steps in your code, I think.
Time steps. In Euler's?
In the modified Euler trapezoidal, there's time steps.
Okay. Let's see. There's a conceptual question on time steps for using Euler's. That's a thing. You'll have to carry out 2 steps of Euler's with a given time step and a given GE and IC.
Wait. What? A GE and IC? The hell is that?
Governing equation, initial condition.
Oh, so can I just solve those with math? I know you're talking about. Can I just like literally? Isn't that just a straight up differential equation type shit?
It is a differential equation, but you have to use Euler's method to solve it because not every method gives you the same answer.
Oh, that's okay.
Precisely. So I highly recommend knowing how to do Euler's. Euler's is easy. It's modified Euler's that isn't so easy.
Isn't there like 3 modified Eulers? Well, there's modified, which is trapezoidal, then there's midpoint. Yeah, there's only three, right? There's midpoint, Euler's method, which is second order, then modified Euler's, which is trapezoidal, which is fourth order, right?
Yes.
All right, cool.
Which I have all of the formulas written on the last page of my review sheet. It's not so bad. And I have the error for all of them. What other questions are on there? Here I got two-step modified.
So I asked Kasab, and he said we would have to do this on the test, and because he went over specific examples with pendulums and stuff, and he was like formulating like specific equations with variables in it, like with the GEs and the ICs. That's why I asked, because I didn't even know what those were. But he was using like the GEs and stuff to like actually form actual equations, and I had no idea what he was talking about. But I think he was talking about I asked him when I asked him that, he was talking about the shooting method, and because in the lecture where he was talking about pendulums, he was going over applicable examples of like making actual general differential equations with the shooting method. I don't know if I explained that clearly, but I don't know.
I'm just trying to understand what you said. Are you talking about like, did he break down a second order differential equation into two coupled ODEs? Or, because I don't think the shooting method is on the exam.
He said it would
I take
be.
it back. I take it back.
He said it is, so unless he lied.
I'm looking at the question right now. It's on there. So there's two of them. One of them's conceptual. The other one is using the shooting method for the governing boundary value problem, an appropriate algebraic equation to use in the finite difference of the boundary condition at x equals L is blank. Did I put shooting method on my?
Yeah, I have no idea what you just read, so I don't know.
Sorry, hold on. Part of it is me like processing. I'm trying to find.
Well, I mean, I know what you just read, but I understand that because that's what I was talking about. That's what he was going over. Because he said, I don't know, Kasab was giving me the juice on the exam. Well, he didn't tell me much, but he did say we had to use it for conceptual type stuff. I think it's setting up equations. Because he said we didn't. It's impossible to solve it by hand.
Luke,
So.
Luke.
Yes, ma'am. Yes, ma'am. Yes.
TAs make the exam, and I'm looking at the exam right now. And I'm telling you, yes, it's on there. One of them is conceptual. One question, conceptual. The second one does have you form, the exact wording is, an appropriate algebraic equation to use in the finite difference of the boundary condition at x equals L is, so you'll be given a general equation, second order, and two boundary conditions. And from there, you have to give an appropriate algebraic equation to use in the finite difference. So.
And I assume that's simple to do.
What's up?
Does he go over that in the lecture for shooting method? I see.
I
to
think
be
he
fair.
does.
All right. So I'm just gonna move from that in. I'll ask you something else.
Hold on.
So I can always.
Okay. I have a very useful tidbit. I remember seeing something that was very helpful. God, I hate this mouse. Okay. Given beam deflection. No, maybe I didn't write it down on this. So, what is the correct answer for it? Let's find out. Hold on. Questions, show details. It'll be the last question on the test. I thought so. I thought it was that. Let's see. Do I remember how to do this? Have
I ruined your like enjoyable like 2-hour period where nobody comes in and just get to sit around.
What'd you say?
Like, I feel like I've ruined your period of time where nobody comes in and like you have like an enjoyable period of time where.
I mean, I don't honestly. I'd rather people come in, so I appreciate that you show up because otherwise I'm just bored. Because like, I don't know, I'm on the clock.
Yeah.
So might as well do something. And half the time I feel guilty doing something that's not modeling methods. So it's like, do I just sit here and wait?
Yeah.
There is something somewhere, and I cannot for the life of me remember where it is. But there is something that has the general form for the algebraic equation you should use for finite difference of the boundary condition. And it might be in the lecture, but the form of it has like, I don't know how to say it, and I can't show you. Yeah, I would look at the lecture slides for that one.
Cool.
Both for, well, yeah, I'd say both for the conceptual and for, because the conceptual question is like, conceptually, what is the process for solving a BVP using the shooting method? Whereas the second one is like, you know, the equation to use in the finite difference of the boundary condition. But yeah, I think those are the
Might
only
have
two.
That's it. I'm just trying to think.
Oh, and do know the error for modified Euler. Like what the equation is. It's in my review guide, but do know how to do that. Because I don't remember if it's in the formula sheet or not.
Yeah.
There's Euler, modified Euler. That's an interesting question. I wonder if they're gonna ask it again. This is another conceptual question about Gauss quadratures that was tripping a bunch of people up. Do I have any other tips for you?
You can leave anytime, by the way. It's after 6, but I'm not going to stop you. If you want to keep talking about it, I'm not going to stop you. But it's up to
I don't know. I don't want to like leave you hanging, and I appreciate the effort that you put in just by being here. So
well, I kind of screwed up because this semester, like I got cocky with measurements. And I was like, measurements is easy as hell. So I shit you not, I got a 15% on a midterm for measurements, but it's only 10% of your grade. So I can get a B in it, but it's impossible to get an A. So I was literally like freaking Michael Jordan in 1996 finals. Like I was like killing every test. And I was like, oh, fuck, I just got a 15%. So I can't get straight A's. So I'm just trying to like, most I can get like a 3.75 like last semester. So I have to like, I don't know. So I can't screw that up. That's why I'm making sure I know everything.
it's okay. I understand. And I appreciate that you are trying your best. So I want to help you because you put in effort this whole semester, I think. It seems like you have anyway. So, okay. I'll give you some more time. Do you have any more questions about things to ask?
All right.
And then I'll have to Tokyo drift through my vibes homework.
The GE and IC for Euler's method.
Yes.
Unless, well, to be fair, a lot of it's like a post. I don't know.
You're what?
The modified, all right, so the modified trapezoidal Euler, GE and IC stuff, I have no idea.
You have no idea?
Yeah.
At all? Okay. Let's see. What's a good way to talk to you about that? I wonder if it's in. Trying to see if it's. Oh yeah, the equations are in the formula sheet, so that'll help you. So let's see. I will pop open my notes again. I did a little bit of this with somebody. I'm trying to remember where I did it though. In my office hours. Because we did. Yeah, we did Oilers, just regular Oilers in one of the projects.
Yes.
Let's see. See if I can come up with a decent.
Did you actually write this octave code for Simpson yourself, or did you like check that, make it? Because I'm still wowed by that. My mind keeps going back to that.
The Simpson and Trapezoidal?
Yeah.
Yeah, that was on me.
What the fuck? That's insane. That's insane. Jesus. Well, you know Python. It's probably close to Python and stuff, so that makes sense. But
I mean, it's all just procedural. I mean, it's math, and I love math. I did like the nonlinear Newton-Raphson in Python. That was really fun.
I literally remember you doing the last lab, and there was literally, I thought you were trolling when you said you made like that, what is the penis or whatever. There was literally, it said like penis graph.m in like your octave folder, and I was like laughing my ass off while you were doing the lab.
I genuinely did it. Well, that one I cheated. I did find an online resource to help me graph it. But it's still one of my prize works, my Magnus Opum. Yeah, I think that's, yeah, whatever, Latin. I used to know Latin. But yeah, I'm very proud of it.
Yeah. Anyways, I got way off track. So.
Anywho, let's see. Can I come up with a decent sample ODE? Well, I guess I could just steal the one from the project. Okay, let's see. Well, that's going to be a second order. I don't want to use a second order. Here we go. Okay. I don't want to use that one either. I don't want to just use the one off of the exam. I mean, I could, but should I? No. Okay, I'll just change up the numbers. So the governing equation will say dy dt plus 3y equals t. And our initial condition.
I can't see anything.
Oh shoot, I'm sorry. I forgot that I stopped screen sharing. Thank you.
You're good.
Hello, come back. My stupid Surface. Anyhow.
Yeah, I think I'm probably gonna buy a tablet. I need one.
They're handy. They are. And
I've been buying shit left and right. I just bought like $1,000 computer.
Jesus.
Like, yeah, so I have to calm the hell down.
Are you like loaded or something? How in the hell?
I took like a year off school and I work like 90 hours a week. So technically, yeah, but I have to pay for all my shit. So I feel like in a couple months I'm gonna be like, oh shit, I actually have to budget. So
That's fair.
I don't know. Not really though, but
I mean, sometimes you gotta treat yourself. I respect it. Anyway.
okay, so GET at what? My eyes hurt.
That's not good. So these are our conditions here, our governing equation and our initial condition. I don't like how close that is to the line. Hold on, sorry. Our note's got to be pretty. Anyway, so using these two things, and where's my formula at? I think that I keep closing shit. I'm gonna reopen it. Just looking. There it is. Okay. So using modified Eulers, we use this color. Y sub I plus 1. Y bar sub I plus 1 equals Y sub I. What? I didn't that right. thing is so stupid sometimes. I love my tablet, but she's also actually dumb as hell. Anyway, I mean, me too. That's why. I'm also dumb as hell. Minus 1, t sub I. And then y sub I plus 1 is y sub I plus delta t. It's a hideous delta. It's still pretty ugly. Anyway. F sub y sub I t sub I plus f of y bar 1 t. I wonder, I'm kind of curious if I still have my work for the final. That would be interesting. I wonder if Dylan did. Range, quadratures, shooting. Oh, for your shooting method, I would look at Dylan's worked examples. He does a nice worked example. Oh, and he does a modified Euler. That's nice. Oh, that's really nice. What a king. Sorry, I'm looking at. You do have Dylan's worked examples, right?
Yes. Sorry, I was muted. Stop me from interrupting you.
Oh, you're good. If you, I recommend looking at Dylan's worked examples, specifically the last page.
Did he literally did this?
Huh?
In his modified, did he literally do this in the modified work examples?
He didn't do like this exact example, but he did do one. Yes, he did Eulers and modified midpoint.
Final review. Sorry, he did not do cubic spline because he failed. But I understand. It's fine.
Well, so with cubic splines, all you're asked for is.
Yeah, I know how to do it, but it's literally just fill in the second order difference things.
Yeah.
Yeah, I just made a formula for. I can see it with these squares. What number is it?
What number is what? It's the last page.
Number 7. I see it on page 7. The last page. Huh?
Yeah, it should be on the last page.
That's it. That looks like he's doing a least squares problem. I think we're looking at different things.
Maybe. Hold on. Here.
Yeah, can I screen share? But
oh, I was just about to drop the one I was looking at in the chat.
Same thing. Yeah, I'm looking at something else. That's why. Yeah. Let's see. What the hell am I looking at then?
I don't know. Maybe he has multiples. Mine's from last semester.
That's why. Yeah. Oh, the one you just sent me is from last semester?
Yeah.
That's why. Yeah. All right. Worked examples. No idea what I'm looking at. Yeah, it's something different. Yeah. All right, last one. Modified Euler. It's quick work. Damn. All right. So he does what you did. All right, sounds good. All right, yeah, I'll let you go. Go off this. Sorry, I've been doing this for since I woke up at 4 a.m. So I've been doing this shit for a while. So I'll let you go. I need to go eat something because I can't understand anything now.
Okay.
My mind's too blank. Yeah, but I appreciate it. Thank you.
Of course. Good luck.
Yeah. Bye.
Bye. What's up, you? Since there's nobody else left in the room and I'm overtime, this is for anybody who watches the recording. There was a couple of points brought up while I was reviewing today. I posted a review, and this review has a couple of errors, specifically regarding the standard error S sub XY. That formula, use the formula sheet for finding that. I highly recommend checking out, well, really just looking at the formula sheet. We did a project on least squares. Least squares is a difficult topic in terms of there's quite a few questions and a lot of math. It's not difficult math, but it's just a lot. So I highly recommend either, well, I suppose, looking at the formula sheet, or I may be posting my project that I did for the least squares project last semester to kind of give an idea of how that would be coded out. A great review tip that I have from taking it last semester, I would highly recommend, if you can, either redoing some of the concepts that we've already done projects on either in Octave, Python, some other language, or just really driving home the procedure on your own, on like paper, a tablet, whatever, just writing it out. I will be publishing the worked examples that I have done today so that you all can see them. And some of these examples have, step-by-step procedures on how to solve things. So I'd recommend checking those out. Dylan has some excellent worked examples. And Dylan and Kyle have posted more comprehensive reviews. The test shouldn't be too hard. There's a decent number of concepts, but quite a bit of math. I'm trying to think of if there's any other questions that I've been given in the last few days that could help people. The biggest one that catches people is like trapezoidal and Romberg integration. We went over that. That's in the notes. There's another linear mapping. Finite difference. Oh, okay. Here's something that I do want to do. So I've been asked quite a few questions on finite difference, specifically when it comes to finding the second derivative, in which I'll share my screen to show it. This is kind of what it looks like. So this is the formula here. This formula, the second derivative finite difference, is on your formula sheet, or it should be. And likely you will be given a table, kind of like this one on the right-hand side. And it's got your x values and your corresponding y values, or f of x, depending on how it's asked. And then you will be asked to find the second derivative, and this arrow points here. So say the second derivative of x sub 2, or when x equals 1. Typically, it'll say, x sub 2. So this is, this right here is x sub 1. This is x sub 2. And this is x sub 3. Because this is, I 1, 2, 3. Anywho, so with the second derivative, you can only find the second derivative if you're given on the 3 points. You can only find the second derivative at this midpoint, the second point right here, because the formula requires that you take the y value evaluated at the x before the one that you're looking at, the y value here, this guy right here, evaluated at the x that you're trying to find the second derivative of, and the y value evaluated at the x after the one that you're looking at. So you couldn't do that if you only, so like, you couldn't be asked for the second derivative at your x sub 3 or your x sub 1 because you don't have the y value after for the x sub 3, and you don't have the y value for the step before for your x sub 1. So as long as you have the formula, super simple, really straightforward. It's just knowing what these mean, which we've seen them a lot. Let's see, that's an important concept, this mapping thing. I went over it earlier in this recording if you were watching. But alas, let's see, trying to make sure, just running through anything I have left that could help you guys. Exam practice, that's all done. Modified Eulers. Yeah, for a lot of the by hand ODE solving, I highly recommend looking at Dylan's worked examples, either from this semester or the last one. It can get a little tricky, but it's not so bad. It's just, you know, keeping track of everything as you do it, especially like modified Eulers, which is using trapezoidal. That one gets a little tricky sometimes, just because you've got your y bar or y caret, depending on how you want to write it, and then you have your y plus 1. Find a difference. Lagrangian interpolation. Oh, I know I did this one somewhere for somebody. At least I talked about it with somebody. So quadratures. I know I did it somewhere. Well, suppose I could briefly talk about it. Not that we need another review session, but sometimes it helps to have things explained multiple ways. So I'm just gonna gloss over it a little bit here. I have sworn I did Lagrangian interpolation in a practice somewhere, but perhaps not. Conceptually, I highly recommend knowing what Lagrangian interpolation does and what cubic spline interpolation does. The fact that Lagrangian interpolation, it's a global interpolation, so basically what you're doing is, the visualization of it is, you're looking at this plot of all of these different data points. So you don't have an equation for it, you just have a bunch of data, and it's thrown onto this graph and looking at it. Well, because it's global, Lagrangian, what it does is it tries to find a polynomial that fits these data points. And it's an nth order polynomial over n plus 1 data points. And it just tries to find one big boy to get as close as it can to fitting your data. Your cubic spline is different. Essentially what it does is, you've got all these points that are out there, and it creates a cubic polynomial to fit between each point. So it's called local interpolation. It's not global, it's just local because it's interpolating between each point. Kind of like how when you make an actual spline. So if you've ever used like a CAD software, And in sketching, you make a spline. Even honestly, it's like it's everywhere. Splines are everywhere. I can't even. I'm trying to think. There's other examples that are more relatable, but because of work, I can only think of SolidWorks. But essentially, you're passing cubic polynomials over in data points, not n plus 1. And to solve, you interpolate, find your continuity of your first and second derivative at these data points, and then you look at your end conditions. And you note both of these interpolation methods are to be used when your data is exact. When it's noisy, that's when you want to try to smooth your noise and pass like a low order polynomial to try to get your best fit. Now, the analysis gets a little bit more difficult, especially when it comes to Lagrangian interpolation. It looks really complicated because you've got all these general equations. It's like, you know, L of n k of x equals 1 equals 0, but it's all based on these main forms. Let's see if I can share my screen. There's two of them here. Anyway, so this looks disgusting and complicated, but really your entire Lagrangian interpolation of all of your data is going to be this polynomial. And so first order polynomial, this piece of 1 of x, this guy, is your entire interpolation of your data. And you find multiple Lagrangian interpolators, which are these kind of coefficients, L sub 1, 0 and L sub 1, 1. Every time you find them, depending on the order of your function, you're going to have, you know, L sub n, comma k, and your k for Lagrangian only goes up to n in this case when we're solving it, and that's surely because of the definitions that we have of these interpolators. So these, highly recommend knowing your each of them. And even this looks kind of confusing because you're like, what the heck does that mean? But really, what it boils down to is you're saying, so your first Lagrangian interpolator is x minus x sub 1 over x sub naught minus x sub 1. And so x is a variable, leave that just as x, minus it's x you're looking at, over x sub naught, which is the one before that, minus x sub 1, which is the one that you are, the data point that you're looking at. And then, oh, actually, terribly sorry, I said that backwards. Because this is your zeroth data point, it's x, so your variable that you just leave as x when you're first finding your interpolator. You plug in whatever x that you're interpolating into later, but you leave that x for now. And then, so x minus x sub 1, which is your next x, not your current one, because we're still, you know, we're saying, hey, we're looking at your zeroth data point over x sub naught, which is your current x, minus the next x, x sub 1. And similar kind of concept, you know, except obviously these values are flipped. These values only work for, well, they don't only work for it. The general definition works for all L sub 1 data points. I think technically they change. I doubt you'll be asked for anything higher than a first order for Lagrangian interpolation, just because it gets a lot more complicated. There's a lot more math. But sorry, I'm cold. Essentially, that's what you've got going on. And then from there, you can construct your polynomial. Likely, when you'll be asked to interpolate, you'll be given a list of x's and corresponding evaluations of your function at those x's. So you plug everything back in, and you multiply whatever your interpolator is by the evaluation of your y at that data point of your interpolator. And then you'll be asked, hey, what's the interpolation at x equals whatever, and that x is not going to be one of the x data points that you have. So it's going to be, you know, the definition of interpolating is you're going to be trying to estimate about what the value of that function would be at that point. So in this case, you would end up with some polynomial, whatever degree. In this case, obviously it's the first degree, and it'll be multiplied through, and you just plug in your x values into the two different x slots here, and that's how you end up with your interpolation. The formulas change, obviously, for the different degree of polynomials that you're looking at. That's when it starts to get a lot more ugly. And you have to start moving even farther forward. So at the 0th data point, you know, every time you see this x where there's no subscript, you want to leave that x where it is, and you plug in. So like for this first one, you plug in your x sub 1. Well, that's a better way to say that. Because it gets a little more confusing when you're asked to interpolate further forward. But I'd say as general practice to think of it as, so you're looking at x sub 0 is likely what you're looking at because you're at your 0th data point. So you're going to be saying x minus x sub 1, which is the next x after that, one step forward after that, times x, keeping that x as it is again, minus x sub 2, which is 2 steps forward, over your current x minus 1 step forward x, times your current x minus 2 steps forward x. And then you solve it. And this interpolator becomes second order because you're multiplying x by x. And that's how it is. And then once again, you find all these interpolators that become, in this case, for second order, they're going to be second order polynomials. You plug those in and multiply by whatever your given evaluation at the different points, so y sub 0, y sub 1, and y sub 2, and they correspond with, you know, your y value corresponds with what value of x of your interpolator, if that makes sense. So your L sub 2, 0, which is your 0th point interpolator, is multiplied by your evaluation of the function at your 0th x. Makes sense. I hope it does. Anyway, same procedure. You multiply them through, and then you add all of these different boys together. Once you plug in your x that you're asked to interpolate. So that is that. I doubt you'll be asked for error because it's really ugly. And it's really hard. Oh, do note higher order polynomials, interpolation polynomials may oscillate. And this is shown by Runge's classic function. It's designed to show that passing a high order polynomial over data all at once causes lots of issues. So it's not like a huge point to know, but just, you know, conceptually I recommend knowing it. So that's all clean data. When we get into the noisy data, that's when we go into least squares, in which there's a lot of statistics, interestingly enough. And I highly recommend, once again, looking at my review document that I had made. And I will make the corrections to that and post it into the Discord probably. But anyway, yeah, it's kind of a process, but you will be asked to find your the matricization. I don't know if that's actually a word, but it gets put into the formal definition. Your data will get put into formal definition. So, you know, it'll be matrix that it's S of X, S of X, S of double X, multiplied by a vector, which is A sub naught, A sub 1, which equals another vector, which is S of Y, S of YX. And then you can analyze that with Kramer's rule to find your A sub naught, A sub 1, which you guys probably talked about, I guess. Let's see, conceptual. Yeah, your fit wiggles is the number of coefficients increases. Conditioning number increases rapidly as the number of coefficients increases. As long as the coefficients are linearly combined, the equations are linear. Yeah. So that's conceptual. It's not super pertinent because I don't think there's very many conceptual questions on these squares. Once again, I'd like to drive home for quadratures. Big things that I highly recommend doing every single time is if you're given a question that starts asking to, you have an integral and you're asked to use Gauss-Legendre or, you know, just quadratures, whatever, however you want to call it, to write down in like a spot for organizational purposes to help you keep everything sorted in your mind. You find your linear mapping, which is your x of x's, and that comes out to be an equation in terms of your independent variable xi in this case, which you plug into later, but you find that and you write it down so that way you have it as a reference and you don't have to like redo it a bunch of times. You find your Jacobian, you write that down so that you always have that for reference. And then from there, it makes everything a lot easier, because once that's written, you'll be given your weights and your x's, so you won't have to write that down. And you can plug in your x's to find your different new x values that you have, you know, your x of x's, which is your mapping. You find your new mapping values, and I'd write those down, but you can, that one's not as bad because it's really easy to find them once you have your function for mapping. All you have to do is just plug in your different x's that you're given, and you now have your different x's. And then, well, I do recommend writing them down, actually, the more I think about it, because then you have to plug those into your function to find your new function values, multiply them by your weights, and then scale the whole thing by your Jacobian, which is why I recommend writing it down. Same thing with like using your integral rules, like your basic and your compound rules, like trapezoidal, Simpson, midpoint. I highly recommend writing down every time what your h is, what your x of naught is, and what your x of n is, and if applicable, what your x of i's are and your i's. Well, I in this case being n. Having that all written out will save you a lot of time and energy, because it'll be there, and you can write down your formulas and easily just plug it in and chug through, and that's easy as that. And I made a little table in my review guide for Romberg that I highly recommend looking at. It makes life easier. I explained a little bit more in depth to Luke, talking about which Romberg formula you choose. So capital T with a subscript is trapezoidal evaluation. And the subscript means how many trapezoids you used. When you're referencing Romberg, the equation will have an I with a subscript to indicate what your approximation of the integral is. But when it's asked for a Romberg, like when we ask you for a Romberg, it'll be asked in terms of O parentheses H to some superscript. And that's how you find which one. Let's see if I'm missing any points. But yeah, the last major thing is least squares is not super fun to deal with. And I do have an error in my formula sheet or my review sheet that I will correct. And I don't know. I don't know how I got an error. But anyway. Highly recommend looking at all of those and using your formula sheet. Formula sheet's super helpful on this one. So anyway, that is all. I'm way over time. Good luck on your exam and yeah, and all of your other finals. So anyway, peace out.